بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة التفاضل والتكامل. مادة التفاضل والتكامل مادة شيقة جدا ومهمة جدا في حياتنا اليومية. أولا في ناس بتسأل كتير إيه هو التفاضل وإيه هو التكامل؟ طبعا احنا عارفين إن التفاضل هو عكس التكامل. بمعنى بسيط جدا، التفاضل لو انا عندي سجادة وعاوز السجادة ديت اقسمها الى قطع متناثرة او من الخيوط، فهو ده اسمه علم التفاضل، يعني بعمل مشتقات جديدة. التكامل لما يكون عندي الخيوط الكبيرة جدا جدا وبجمعها في قطعة واحدة او في صورة سجادة، وهو ده معنى التكامل. Welcome my dear student in our math program for second 3. Today we are taking new lesson in calculus differentiation. It's called problems about behavior of the function. What is the meaning of behavior of the function? My dear student, the function is the human has increase interval and decrease interval and constant interval. My dear student, look at the first example about behavior of the function. My dear student, determine the increase and decreasing interval for function f, where f of x equals x plus 2 sine x, where x more than 0 smaller than 2y. My dear student, the required how to determine increasing and decreasing intervals for the function f, where the function f x plus 2 sine x and x more than 0 smaller than 2y. My dear student, look at the solution. F is continuous and differentiable on same interval open 0 to pi. The first, find the first derivative of the function f dash x equals 1 plus 2 cosine x. How to investigate the sign of f dash x? My dear student, at the first we put f dash x equals 0, then 1 plus 2 cosine x equals 0. To find the value of x, my dear student, cosine x equals negative 1 over 2. What is the value of x? My dear student, by using calculator, x equals 2 pi over 3. What do you mean of 2 pi over 3? Equals 120. Which value of x? When cosine x equals negative 1 over 2, then x equals 2 pi over 3 or 120. My dear student, and the equivalent of 120 or 2 pi over 3 equals 4 pi over 3. Remember, my dear student, x belongs open interval 0 to pi. 120 or 2 pi over 3 lie on the second quad, and the third quad 4 pi over 3. My dear student, we obtain table. This table consists of 3 intervals. From negative infinity, 2 pi over 3, the first interval. Second interval, from 2 pi over 3 to 4 pi over 3. Third interval, from 4 pi over 3 to infinity. The sign of f dash x in the first interval, positive. Second interval, negative. Third interval, also negative. Fourth interval, equal positive. Therefore, what is the behavior? If the f dash of x is positive, my dear student, then we know that f of x is increasing. Second interval is negative. F dash of x, when substitution about x equals belongs to open interval 2 pi over 3 to 4 pi over 3. 2 pi over 3 equals what? 120. 4 pi over 3 equals what? 240. Then if we choose value of x between 120 and 240 as 150, 200, and substitution about f dash x, the sign is negative or the number smaller than 0. Then in this interval, the function or behavior of the function is decreasing. The last interval from 4 pi over 3 or what? Or from 240 to pi, then f dash of x is positive. In this interval, the function is increasing. Another example. Determine the increasing and decreasing interval of the function x power 3 minus 3x squared minus 9x plus 1. My dear student, determine increase and decreasing interval. Look at, my dear student, at the first, when find increase and decrease, let f dash of x equal 0. What is the f dash of x, my dear student? 3x squared minus 6x negative 9. After that, f dash of x equals 0. Then we divided each term by 3 to simplify x squared minus 2x minus 3 equals 0. And factorize by using trinomial. Then x plus 1 multiply bracket contains x minus 3 equals 0. Then x equal negative 1. Also x equal 3. My dear student, look at on the number line from negative infinity to infinity. The first interval, negative infinity open to negative 1. Second interval, from negative 1 open to 3. Third interval, from 3 to infinity open. My dear student, in this interval, from negative infinity to negative 1, let f dash of x is positive. Then we choose the number between negative infinity and negative 1 as negative 2. Negative 2 belongs to open interval. We find f dash of negative 2. We find f dash of negative 2 is 15. 15 more than 0. This is positive. The sign is positive. This function increasing of first interval from negative infinity open to negative 1. Therefore, my dear student, f dash x more than 0 for all x belongs to open interval negative infinity to negative 1. F is increases in this interval. My dear student, look at the second interval. We have the second interval negative 1, 3. We choose the number between negative 1 and 3 as 0. 0 belongs to negative 1, 3. We find f dash of 0. Then f dash of 0 by substitution about x equals 0, answer is negative 9. What about negative 9? Smaller than 0. Then this function is decreasing in negative 1 and 3. F dash x smaller than 0 for all x belongs to open interval negative 1, 3. Function f decreases in this interval. We translate the third interval. In the interval 3 infinity, we choose number belongs to open interval 3 infinity as 4. 4 belongs to open interval 3 infinity. F dash of 4 equals what? Equals 15, more than 0. What about 15? Positive. Then the function f dash x more than 0 for all x belongs to open interval 3 infinity. F increases in this interval. My dear student, look at another example. Determine increasing and decreases interval of this function third x minus cubic root x. My dear student, this function the required find increasing and decreasing interval. My dear student, we have steps. The first step, find f dash of x. After that, we find solution set which makes f dash of x equals 0. After that, find the value of x. We have 2 intervals or 3 intervals. We suppose any number belongs to the first interval and find f dash of this number. If f dash of this number more than 0, then f of x is increasing. If f dash of x smaller than 0 or negative, then, my dear student, the function is decreases. My dear student, look at the solution. Dear student, look at f dash of x, third minus third, x power negative 2/3. Suppose, my dear student, x not equal 0. Why? Because if x equals 0, the function is undefined. Then, my dear student, look at the function value of x, 1 over 1 equals 1 over cubic root x squared. Therefore, my dear student, x power 2/3 equals 1. My dear student, if x power 2/3 equals 1, what is the value of x? Then, if we have x power 2/3 equals 1, what is the value of x? In this case, we have more method to find the value of x as for all power 3, or the left hand side x power 2/3 for all power 3 equals 1 power 3 equals 1. Then left hand side became x squared equals 1. What is the value of x? Positive or negative 1. Then, my dear student, we have 3 intervals. First interval from negative infinity to negative 1. Second interval from negative 1 to 1. Third interval from 1 to infinity. In the first interval from negative infinity to negative 1, we choose the number in this interval. We know that f dash of x more than 0 is positive. Then the function is increases in this interval. Second interval, my dear student, open negative 1, 1. We choose the number between negative 1, 1 as 0 and find f dash of 0. Then we find at f dash of 0 smaller than 0 or negative. Then the function is decreases in this interval. In the third interval, 1 infinity open, we choose number belongs to open interval 1 infinity as 2 or 3 or any number. Find f dash of this number. We find this f dash of this number positive or more than 0. Then function is increases. F dash x more than 0. Then the function is increases in this interval. My dear student, now we are translate two important title. It's called absolute maximum value of the function on closed interval. My dear student, this title very important title. The absolute maximum values of a function on closed interval. Theorem 1, my dear student, for the function f defined over the interval open interval AB, differentiable, and x1 belongs to open interval. The first, my dear student, we have function f defined over the open interval, and we have point x1 belongs to open interval. Then f of x1 is a local maximum or minimum of the function, then f dash of x1 equals 0. Remark, my dear student, if the function f differentiable function and f dash of x equals 0, it is not necessary function has local maximum or minimum value at this point. Remark, my dear student, if the function differentiable and f dash of x1 at x1 equal x1 belongs to interval open interval as AB, then f dash of x1 equals 0. It is not necessary that if local has local maximum or minimum value at this point. My dear student, look at this example. My dear student, this example, y equal x power 3, cubic function. Cubic function, my dear student, we were studied in the last year in secondary. Y equal x power 3, the curve in first and third as the opposite figure. The origin point is symmetry to the curve, then the function is odd. My dear student, y equal x power 3, when find dy over dx equal 3x power 2. My dear student, if we put f dash of x equals 0, then x equals 0. My dear student, f dash of 0 equals 0, neither maximum or minimum. Theorem 2. Look at, my dear student, we have the function f is continuous. Look at the opposite graph. The function is continuous. At x1, f dash of 0 more than 0 for all x, f dash of x more than 0 for all x on left of x1. But f dash smaller than 0 for x on the right of x1, on the left x1. My dear student, the function has local maximum at x1. Why? Because at left x1 less than 0, but more than x1, or at the right x1 less than 0. Second, if the function f is continuous, f dash of x more than 0 for all x on the right of x1, f dash of x smaller than or equal 0 for all x on the left of x1, then the function has local minimum at x1. Follow the absolute maximum value of a function on closed interval. Theorem 3. My dear student, if the function differentiable and f dash of x equals 0 and f double dash of x1, which x1 belongs to interval smaller than 0, my dear student, this theorem very important. The first, we have function differentiable on this interval and f dash of x1 equals 0. And f double dash or second derivative of the function on this point smaller than 0. What you deduce? X and student. Then the function f has local maximum value at this point x1. Remember, f double dash smaller than 0. Then the function has local maximum. But my dear student, if the function differentiable and f dash x equals 0, also f double dash more than 0, what you deduce, my dear student? X and student. The function f has local minimum value at point x1. Example. Find the local maximum and local minimum of f of x equals x power 4 minus 12 x power 2. Solution. At the first, my dear student, we find f dash of x and find f dash of x equals 0. At the first, f dash of x equal 4x power 3 minus 36x. By taking 4x highest common factor, then f dash of x equals 4x multiply bracket contains x squared minus 9. Then, my dear student, we factorize x squared minus 9, x minus 3, inside bracket multiply another bracket x plus 3, then we put f dash of x equals 0. Before that, find f double dash equals 12x squared minus 36. F dash x equals 0, then what is the value of x? x equals 0, x equals 3, x equals negative 3. My dear student, we have three values of x when f dash x equals 0. Then f dash 3 equals 72. F double dash then has this positive local minimum. Also f double dash negative 3 equal 72 also has local minimum. F double dash 0 equals what? Negative 36 smaller than 0 has local maximum. My dear student, now we are translate to important title concave and inflection point. Definition. Continuous part of a curve is said to be convex upwards if the curve lies over all its chords. My dear student, a continuous part of curve is said to be convex upward if the curve lies over all its chords. Continuous part of a curve is said to be convex downwards if the curve lies under all its chords. Look at my dear student. This convex up. Why? Because the curve up the chord. Convex down because the curve under the chord. Look at my dear student. Very important theorem. If the function f is differentiable twice or has second derivative on open interval ab and f double dash x smaller than 0 over interval, then the graph convex upward over this interval. Number 2, if the function f is differentiable twice or second derivative on open interval ab and f double dash x more than 0, we deduce that f is convex downwards over this interval. Look at the following definition. A point of inflection point or inflection point on a curve of the function is that point at which the curve changes its concave or concavity from up to down or from down to up. What do you mean inflection point, my dear student? There is difference between inflection point, my dear student. Inflection point respect to f double dash or second derivative. Inflection point means the curve changes its concavity from up to down or from down to up. Given that, my dear student, f dash x equals 30x power 3 minus x squared minus 3x plus 7. F dash x 30x squared 30x power 3 minus x2 minus 3x plus 7 when x belongs to closed interval negative 2, 4. Find the critical point of f. Find the interval of increasing and decreasing. Also find local maximum and minimum. Number 4, find the absolute maximum or minimum. My dear student, f dash x squared minus 2x minus 3, f double dash 2x minus 2. F dash x equals 0, then x squared minus 2x minus 3 equals 0 by using factorization x equals 3 or x equals negative 1. At the first, 3 negative 1, 3 negative 2 and negative 1, 26 over 3 are critical points. Look at the interval First interval, negative infinity to negative 1, negative 1 to 3, 3 to infinity. My dear student, the first is increasing, second interval decreasing, third interval is increasing. Increasing for all x belongs to the first interval, negative infinity to negative 1, union, open interval 3, infinity. And decreases for all x belongs to open interval, negative 1, 3. Using theorem 2, negative 1 to 26 over 3 is local maximum point, 3 negative 2 local minimum point. F of negative 2, 19 over 3, also f of 4 equals third. Comparing this local maximum value 26 over 3 and minimum value negative 2. Therefore, absolute maximum equal 26 over 3. Also, absolute minimum negative 2. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.